So I want to clarify questions for a little bit further. The way that the questions are assigned in this assignment is so that one is built upon another. And in question 3 is built upon the knowledge that you have here. So in question 3, let's go back to similarity measurements. In similarity measurements, we have two binary vectors. So in the slide, you have x going from 1 and y going from 0 to 1. And in order to use Python to do that, we need to provide Python with two variables x containing this list of 1 and 0, which is what we have on the slide, y containing list of 1, 0 and 1s, which is equal to the value we have on the y. So here, you see on the slide, you see x as a sequence, y as a sequence of character. But when we are converting it to Python programming, we have to think of it as an array of individual value, 1 and 0 and 0 and 0 and so on. So then we need to start to calculate the F01, F10. So F01 on the slide is the number of attributes where P was 0 and Q was 1. So let's forget about the Python deck on the right and focus on the left. We need to count for F01. So P was 0 and Q was 1. So starting out 1 0 nope 0 0 nope 0 0 nope da 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 0 1. This is when you have the first value of F01. So F01 is now 1 and 0 0 0 0 nope 0 1 another. So F01 is now 2. So that was the logical thinking on this slide. So how do we express that in the programming? We have to count F01, but we have to start from something. When we did it, logically, you see I jump directly into F01 equal to 1 and then F01 equal to 1 over here. And I skip one very crucial step. And all of us, all humans, skip that step is you have F01 as 1 and then 2. So what was it before then? We assume that this was 0. This is one step that we assume when you count something. You count your invitation card, you count the email you have in your inbox. You would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The one step that we never mentioned is what was the count at the very beginning. And this is 0. And we knew that as human. But the program doesn't know that. So at the very beginning, you have to make that explicit step, F01 equal to 0. And then we go to the loop and we start going through the list. And so we go through the list, and this is the conditions. We check for the condition 0 and 1. X equal to 0, y equal to 1. You increment, so you count one more level to F01. And then this is the condition else if, else, and so on. So how does that apply to question 4? In question 4, we want to calculate the cosine similarity. So we have the exact equation here. Question 4 is actually somewhat more straightforward than the checkered similarity and the similarity between two binary vector, because we don't have to check for if P was 0 and Q was 1, P was 1 and Q was 0. The value that we need to calculate for the cosine similarity is the inner product and the length of the vector d1 and length of the vector d2. So these are the three values that we have to calculate, which is here, the inner product, the length of d1, the length of d2. So how do we calculate the inner product? And again, we don't need to go outside. At this moment, what I want you to practice is looking at the equations that we are given and able to express it in Python code. So again, we cannot explicitly saying what we need to initialize it, inner product equal to 0. The machine doesn't know that. The computer doesn't know it. We know it. We start the count at the value 0. We don't start at -1. but we need to tell the computer that you start at 0. So what is the range for I? Here, D1 equal, D2 equal. I'm looking for you to do something similar to this step. You need to define the array containing the element or the attribute points for D1 and D2. D1 and D2 play the same role as X and Y. Inner product equal to 0, initialize this. This is where we perform this code for the inner product. The only difference is that you are adding everything. So 3, 1, 2, 0, 0, 0, 5, 0. You can see how each of this. This is the increment step. If I was to do F0 and 1, if I was to write out individually, I would have write out 0 plus 1 over here. In this case, there's no condition, so you are going to step through every position of D1 and D2, multiply the corresponding value at that position. So you can see here, xi and dyi. So what are those values correspondingly for D1 and D2? And we add all of them together. So this is inner product. In this here, you see these equations. We add all of them together. You could write this directly without a for loop into your code as well, but we don't want to do that. I recalling reading in one of the assignment submissions about someone was working with hundreds, close to 1,000 of attributes, meaning that this can extend to have close to 1,000 attributes, and you really don't want to type out 1,000 equation over here. So this is when you would go through and do a loop, step through each position. This is position 0, position 1, position 2, all the way until position 9, since we are starting from 0. So what is the range? The range would be similar to what we have here. And then after that, you have the inner product. To calculate the length of D1, similar equations as the inner product, but this time you are taking the value of each array, the observations, and multiply that value by itself. So instead of xi, yi, it would be xi, xi, for example. So I have here, so this 3 steps are very similar in terms of logical flow and the overall programmatic flow. Only slightly different is you are applying to different elements. And once you have all of that, the cosine similarity equation is already here. And if you run this cell, you will get the result back.